All right, so I'm writing this one to be, this is number 11, and we're in chapter 10. And I'm just going to write this as matched pairs test/interval. Since it's technically like one we've done before, I don't see the reason in doing two separate ones. Alright, so you've got this vertical line, like right here is your title. I would like to write a couple things right here. This is only with means. Not that this is an indicator, but it definitely can only happen if what with the sample sizes. They absolutely have to be the same. So that doesn't make it a matched pairs, but obviously that has to happen. And the samples are not independent of each other. Or reason to group. I'll put reason to circle pairs. That's my weird way of saying there is a reason to do that. I wrote circle pairs. I know you can't see it in that blue. Alright, so what did we write? What's our first part of state, and regardless of which one sample mean thing you're looking at? Population, which now we've talked about, can I define population within? So either way, if you want to do it separate or don't want to do it separate. But I also have to define what? Mu. Now, this one we are always going to define as mu d. And most of my answer keys have this. But one year I started to notice that my sloppiness, my subscript capital D started to look like O's. So for my terrible handwriting, I switched to these just so that it was more obvious when you were looking at it. But most of the time in a textbook, you see it as a capital D, but it doesn't really matter. So what is the D for? Why D? Difference. And then context, population. And just like I said, we could have written population separately, but we've kind of gotten to the point where a lot of times we write it within defining it itself. But what did we have to do for all of chapter 10? Like somewhere up here, we had to be clear that we chose what? We had two samples. So think about the homework. You could have done it two different ways. So somewhere in state, you had to define what? The direction, which one you subtracted. You have to specify that here because we're not always going to have words below that. So if we were doing the example that we did in class, I could even write the true mean difference in times holding breath for AP Stat Leonard students, and then write in parentheses sit minus hop if I had defined that somewhere. So like you literally just need to say which direction you subtracted. Since we don't have two mu's to subtract, it's usually just going to be wording there. Alright, so I am doing ones, like I'm going to test and interval on the same slide because there's no reason not to. So if it is an interval, then I go to what? Want to estimate the true mean difference which is mu d, and then how does that finish? Because it's an interval with whatever percent confidence. If it is a test instead, I do what here? Find your what? Or write your what? Null and alternative hypotheses. So null hypothesis is just going to be what? What first? Mu d. What symbol has to go here? Now this is one of those where this can technically be any number, but almost always that's going to be what? 0. And it is a test, so what else do I define in state? Alpha. And then, same as always, you'd use 0.05 if one wasn't given. So I'm not going to go through a whole problem like this written all the way out as an example problem. We're going to do like we did yesterday and jump straight into it. So let's talk through this part with our example we did in class. We would say let mu d be the true mean difference in what? I already said a little bit. For our class example, would be the true mean difference in what? What did we measure? Amount of time students could hold their breath for students in Leonard's AP classes. And I would write, because I didn't write any more context in that, I'll probably have to write sitting, eyes closed, minus hopping. Unless I had like a key off to the side with the S and the H. Which wouldn't change much of anything here. Depending on what we wanted to test, that's always the same. That's not going to change. All right, so plan. What's our first part of plan? Method. So now, even though we are in chapter 10, this is a how many sample?
One sample.
This is a one sample. And so matched pairs is the one thing that's thrown in there that isn't usually. I don't care if you choose to do it at the end instead. What's my next usually decision? Before that, Z or T, but I told you it's always going to be T because it wouldn't make sense to have a parameter value for a variable that we made up. I would by habit, but I'm not going to cut off here. And then, since I'm writing this as combined test / interval, some of my answer keys, and I've steered away from this because I think some people got confused by it. When we do 2 sample, it's difference in means. But when we do it this way, it's not difference in means. It's the mean difference. So just if you see it somewhere along the way. Check conditions. Now, with this one actually is a tiny bit different. When are we doing a matched pairs? We are doing matched pairs if we are conducting a what? If we are conducting an experiment, which one of these am I going to be dealing with? So, random assignment. And then there's no good way to write this because it's going to change with context every time. So for our particular example, where did the randomization part for the random assignment come into play? So not thinking wording here, literally what we did in class, what part was the random assignment? So which one you did first? So the rolling the die. So we would say random assignment of which treatment was first. That one sounds kind of weird still. I would write something like roll the die to determine which treatment was received first. Does that make sense? So like it's going to be something with that. Every single problem is going to be worded different, so there's not a good way to write that clean as like a fill in the blank. All right, what's my next condition? Well, we're dealing with means, so how many ways do I have to check for normal? What would my first one be? I'm going to write this one, but what would the population distribution be? We're finding the what's. Should we really expect that much?
No.
But there can be ones where it's like, it seems reasonable to assume that they would be approximately normal. So like, in actuality, should we be told that? No. But in the practice of statistics, it actually does happen more than you would think because they're using that assumption to be able to do the rest of it. All right, what's my next option? Central limit theorem. What's my third option? All right, so we've got to think here. We're given 2 different data sets. We find, or what looks like 2 different data sets. We're finding a third. What do I need to make a histogram of? Just the differences. So that's why sometimes I actually go through the fact of don't use those for anything else at all whatsoever once you have found the differences. If it is one of these types of problems, don't make a histogram of it, don't find standard deviation of it, don't anything. So we are making a histogram of differences here. And I would underline, star, highlight something just because that's the one thing that actually changes. And then we're still checking for what 2 things? No strong skew. And no extreme outliers. And regardless which one of the three we end with, we can use no approximation. Last condition, independent, which is 10% condition. This is another one of those that gets to be a funny area of. No, I don't want to mention that. I don't want to off. Same way we've always done it. Alright, do. What are we given from? What do we always start with for means? And this one is going to be x bar what? And then what else do we need from D? And now sometimes people just write N instead of ND. Why is it okay? Why do some people write N instead of ND? Because the size for this first sample and your second sample and your difference are all the same. But just out of habit, I always write it. Because I'm writing it for both, sometimes I also need what? If it's an interval, I'm given, or if it's a test, I'm given mu naught, alpha, 1 or 2 tail. So if it's an interval, what's our equation going to look like? What goes here? What goes here? I forgot to write what? With this one? With this one? Is that what you're talking about? Oh, with this one, yeah. I'll stick it in the red. And some of that, like, yeah, it should be written there, but usually I'll do it out of habit. That's not something where 4 months from now you're going to look like that's going to help you do well on that AP exam. To write that, I don't think. And most of the time, with a lot of the stuff that I write up there, I write more than once on purpose, just in case. So then what's here? So we keep having all of these different equations, but are they really that different? Like the format for your interval is always the same. Value plus or minus critical value, standard deviation. If we are doing a test, what goes on top? What goes here? And so some people are going to write mu naught, which is more correct. I'm okay if you just write that, if you know where that comes from. Whichever one you would rather write. I wrote it as number here. So because of that, I would probably write it as number again, or switch both of them to be mu naught, which is the more correct way to do it. And then what goes in the denominator? SD divided by square root of ND. And then if it were this, we draw and shade, find our p-value. If it were this one, what's our thing in the middle? USD. And now, I'm still writing both concludes in that space. So kind of save yourself room however you want to do it, or if you want to do one line then the other line. If it is an interval, we're going to say we what? So write it the same way we started, state. That true mean difference. Mu D, and then what? Falls between. Just like with the ones from the rest of chapter 10, you get to pick which one you write first, which might change your alternative. Same thing with this. If you choose which direction to subtract, your answers might be like the opposite positive negative of somebody else. That's fine. And then so if it's a test, we'll write our regular test conclusion. What are our options? Reject or fail to reject. What are we rejecting or failing to reject? And that's part of why I don't write mu naught, is because my terrible little d's look like O's, and if you write something that looks like mu naught equals mu naught, that gets confusing. These should be mu naughts if you want to write it correctly. So we've got to reject null hypothesis, mu d equals number, since what? Means that we do or do not have enough convincing evidence that, whatever your alternate hypothesis is.